Now we're going to look at examples where we actually do not have a bound. So let's take a look at this graph right here. We have to write the domain as an inequality. So if we look right here, remember we have to get 2 points. We have to get the endpoints, the point that is farthest to the left and the point that is farthest to the right. The point farthest to the right is easy to spot here. We can see that it's going to be this one right here, which is a closed circle. So let's go ahead and slice this with a solid line. So once we slice this, we can see that this closed circle, the x value that corresponds to this closed circle is 4. So let's go ahead and mark that down here. We have a positive 4 on the right. Now on the left, you may be tempted to say that the point that is farthest to the left is going to be this one right here. But you can see that this segment, it doesn't have an endpoint on the left, so we're going to be under the assumption that it's actually going on forever. So here we're going to mark an arrow here, and we're going to say that this arrow is extending towards infinity. Now we can see that on the left hand side there is no way that we're going to be able to get the point that is farthest to the left, because if you say this point right here is the point that's farthest to the left, then I can say, well, this line actually goes to infinity, so we can extend this right here. And now you can say, okay, then this point is the one that's the farthest to the left. But then again, you're like, no, because this is an arrow, so it keeps on going forever. So whatever point you choose, I can always pick another one that is farther away. And that's where this concept of infinity comes from. However, we have to be a little bit careful on how we write this. If we look at the x-axis, we can see that these values are getting smaller and smaller and smaller, right? I rather owe $1 than owe $10, right? So the more that this graph extends to the left, the smaller that the value is going to get. So here, since it's getting negative, 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 we say that this graph is going to go towards negative infinity. Now let's express our domain using an inequality. So on the left, we have negative infinity, and on the right, we have a positive 4. And we have x in the middle. Let's start with the right side first. The 4 is correlated to a closed circle, so we're going to use the less than or equal to symbol. Right, we're going to emphasize that bar below the alligator looking symbol. And now on the left hand side, we have negative infinity. Every time you have any sort of infinity, you're never going to put the equal sign. So this one's just going to be less than. So negative infinity is less than x. And then less than or equal to 4. And that would be a great answer. However, we can get a little bit more technical. If you write your answer like this, then you're gonna show everybody that you're a beginner. But we don't want to be beginners. We want to be more fluent with this. So every time you have infinity, you can technically ignore that. So I'm gonna cut this section off, and I'm just gonna write x is less than or equal to 4, and that would be my domain. Let's do one more example. So here we have to express the domain as an inequality, and we have to find the endpoints. Let's begin with the left this time. We can see that the point that's farthest to the left is going to be this open circle right here. So let's go ahead and slice this with a dotted line because we have an open circle. And we can see that the x value that corresponds to this open circle is going to be -2. So let's go ahead and record that up here. So we have a -2 for the lower bound. And now let's look at the point that is farthest to the right. So if we look here, we can see that no point is being specified here. So we're going to go under the assumption that this is an arrow and it's going forever, it's extending forever on the right. So we come to the conclusion that we can't get the point that is farthest to the right because this is going to keep on extending forever. So here, since this arrow is extending to the right, let's pay attention to the x values and let's see what is going on here. So as this graph keeps on extending, you can see that these x values are getting bigger and bigger and bigger to the point that we're going to approach positive infinity. So this time we're approaching positive infinity. Let's record the inequality now. So the variable is x. On the left hand side we have a -2, and on the right hand side we have a positive infinity. Let's pay attention to the -2. The -2 correlates to an open circle. Since we have an open circle, we're going to use a strict inequality. Okay, we don't put the bar underneath it because it's open. On the right hand side we have infinity, and remember, for anything that involves infinity, we always just use the strict inequality. We don't put a bar underneath. But again, this is the way a beginner would write this down. So let's write this down more proficiently by getting rid of this infinity section, and we can write this as -2 less than x. So that would be the domain.